Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are students from Faculty of Science and Technology, Walisongo State Islamic University, Semarang, Indonesia. Today, we are pleased to present our research entitled Dual Action Potential of Ferric Oxide / Calcium Oxide Bifunctional Catalyst as a Bridge for Simultaneous Reactions in Biodiesel Production from High Free Fatty Acid Castor Oil. Petroleum is still the world's main energy source, and its consumption continues to rise due to economic and population growth. However, the heavy use of fossil fuels leads to resource depletion and increased carbon dioxide emissions that contribute to global warming. Biodiesel offers a promising renewable alternative. It is environmentally friendly, biodegradable, and can be produced from biological resources. To avoid competition with food suppliers, the development of biodiesel from non-edible feedstocks has become increasingly important.
One potential feedstock for biodiesel production is castor oil. Castor oil is a non-edible feedstock, so its use does not compete with food research and can significantly reduce biodiesel production costs. It contains about 89% linoleic acid, which give a favorable properties such as high viscosity and a low freezing point. In addition, castor oil dissolves more easily in methanol than many other vegetable oil, making it a promising and sustainable feedstock for biodiesel production.
Biodiesel is commonly produced through classification using a catalyst. Calcium oxide is widely used because it is inexpensive, abundant, and highly active. However, calcium oxide has several limitations, including catalyst activation and reduced performance when processing feedstock containing free fatty acids. Castor oil contains 0.56 until 2.76% free fatty acids, which can cause shock formation and lower biodiesel yield. To address this issue, a biofunctional catalyst containing both acidic and basic active site is proposed. The acidic sites catalyze esterification of free fatty acids, while the basic sites promote translocation of triglyceride, enabling both reactions to occur simultaneously in a single-step process. In the study, ferric oxide was used as the acidic component and impregnated onto calcium oxide to produce a biofunctional ferric oxide / calcium oxide catalyst. Ferric oxide is known to catalyze esterification reaction due to its Lewis acid properties, enabling esterification and trans-esterification reaction to occur simultaneously. In addition, the presence of ferric oxide can improve catalyst stability and enhance the absorption of carboxylate groups and free fatty acids. Based on this consideration, the study aimed to characterize a 7-way ferric oxide / calcium oxide catalyst and evaluate its catalyst activity in biodiesel production from castor oil.
The bifunctional ferric oxide / calcium oxide catalyst was synthesized using the impregnation method. Initially, 30 grams of limestone were calcined at 800 Celsius for 6 hours to produce calcium oxide as the support material. Subsequently, calcium oxide was impregnated with ferric nitrate monohydrate solution to obtain catalyst composition of 7% ferric oxide / calcium oxide. The mixture was stirred at 80 degrees Celsius for 4 hours, followed by drying and recalcination at 900 degrees Celsius for 3 hours to obtain the bifunctional catalyst. To confirm the successful synthesis of the ferric oxide / calcium oxide catalyst, several characterization analyses were performed. First, FTIR characterization was conducted to identify chemical bonds and detect the functional groups present in the catalyst. Second, XRD characterization was used to determine the crystal structure and confirm the presence of the catalyst phases. Third, the acidity of the catalyst was evaluated using the gravimetric ammonia adsorption method to determine the amount of acidic active acids. Finally, the basicity of the catalyst was analyzed using Hammett titration with 0.1 normal benzoic acid to determine the amount of basic active sites. The FTIR result showed that the ferric oxide / calcium oxide catalyst retained the characteristic absorption bands of calcium oxide, including OH, HOH, calcium hydroxide, carbon dioxide, carbonate species, and calcium-oxygen bonds. In addition, a new absorption band appeared at 725.09 per centimeter, corresponding to iron and oxygen bond vibrations. This finding indicates that ferric oxide was successfully impregnated and dispersed on the calcium oxide surface, resulting in the formation of the bifunctional catalyst. Further characterization was carried out using X-ray diffraction. The diffraction pattern still exhibited the characteristic peaks of calcium oxide, along with the appearance of a ferric oxide peak at 2 theta angle of 62.65 degrees. Additionally, a peak shift from 64.33 degrees to 64.23 degrees was observed. indicating an interaction between ferric oxide and calcium oxide. These results confirm the successful formation and impregnation of ferric oxide onto calcium oxide matrix. Furthermore, the acidity and basicity analyses were conducted to verify the bifunctional properties of the catalyst. The results showed an acidity value of 7.4 millimole per gram, indicating that ferric oxide impregnation successfully introduced acidic sites into the catalyst. Overall, the ferric oxide/calcium oxide catalyst possessed both acidic site and basic sites, confirming its bifunctional nature and its ability to catalyze esterification and trans-esterification reactions simultaneously.
The catalytic performance of ferric oxide/calcium oxide was evaluated in biodiesel production from castor oil. The reaction was carried out using a methanol to oil molar ratio of 9:1 at 70 Celsius for 3 hours with 1.5% catalyst. Unlike calcium oxide, the ferric oxide/calcium oxide bifunctional catalyst contain both acid and basic active site. The acid ferric oxide site catalyzes esterification of free fatty acid, while the basic calcium oxide site promotes trans-esterification to triglyceride. As a result, both reactions can occur simultaneously in a single-step biodiesel production process. The results show that the ferric oxide/calcium oxide catalyst produces lower fatty acid methyl content is 20.03% and biodiesel yield is 18.61%, then calcium oxide with achieved 31.49% fatty acid methyl ester and 27.31% yield. However, the bifunctional catalyst demonstrates a clear advantage is reduction free fatty acid. It achieved 71.35% free fatty acid reduction, significantly higher than the 44.8% obtained with calcium oxide. As a result, the biodiesel produced using ferric oxide/calcium oxide exhibit better quality with a lower acid value of 1.05 mg kalium hydroxide gram and a residual free fatty acid content of only 0.53%. This result indicates that although the fatty acid methyl ester content and yield were lower, the ferric oxide/calcium oxide bifunctional catalyst was effective in processing free fatty acid containing castor oil and improving biodiesel quality through simultaneous esterification and trans-esterification reaction.
In conclusion, a 7% ferric oxide/calcium oxide catalysts were successfully synthesized using the impregnation method, Fourier transform infrared spectroscopy, X-ray diffraction, acidity, and basicity analysis confirmed that the catalyst possesses bifunctional properties with both acidic and basic active sites. Although the fatty acid methyl ester content and biodiesel yield were lower than those obtained with pure calcium oxide, ferric oxide/calcium oxide catalysts demonstrate a significantly superior ability to reduce free fatty acid content. Therefore, this catalyst shows strong potential for processing high free fatty acid feedstocks such as castor oil. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.